This is the Synthetic Signal Report for Friday, May 29, 2026 in the morning. Today, we analyze the performance of real-time inference on standard hardware, the granular configuration of Claude code, the blocking of Home Assistant by Volkswagen, and an MIT breakthrough in lithium extraction. We also cover the hardware constraints imposed by AI energy demand, pediatric autoimmune research, and a multi-phase framework for AI cognitive diversity. A significant report from the technical community details a breakthrough in real-time language model inference. By optimizing software stacks, researchers are achieving 3,000 tokens per second per request on standard graphics processing units. This leap in throughput effectively eliminates the latency bottleneck for many agentic workflows. It suggests that high-frequency reasoning tasks, previously confined to massive cloud clusters, can now be localized. For independent developers, this means the cost of running intelligent agents is dropping as hardware utilization efficiency climbs. New analysis into the internal source code of Claude Code has revealed a variety of undocumented configuration parameters. While the provided documentation offers a surface-level overview, the code reveals hidden hooks for request prioritization and context window tuning. This disclosure is vital for engineers who need to force deterministic behavior in coding agents. By manipulating these underlying settings, users are finding they can bypass some of the rigid, vendor-enforced constraints that frequently plague agentic development. Volkswagen has initiated a technical blockade against the Home Assistant community. By requiring client assertion for vehicle data access, they have effectively broken the integrations used by open-source smart home enthusiasts. This is a classic case of vendor-led enclosure. By forcing users into a proprietary, assertion-based authentication loop, the company is stripping local control from vehicle owners. The community response is currently focused on reverse engineering these new assertion checks to restore local fleet management. Researchers at the Massachusetts Institute of Technology have unveiled a low-temperature process for lithium extraction. Historically, this required baking rock at over 1,000 degrees Celsius, an energy-intensive and carbon-heavy process. The new technique uses chemical leaching at significantly lower temperatures to pull battery-grade lithium from common minerals. This is a critical development for the battery supply chain. By reducing the energy cost of extraction, the process makes previously uneconomical deposits viable and lowers the overall environmental footprint of electric vehicle production. Community chatter highlights a massive shift in semiconductor constraints. A senior executive at Taiwan Semiconductor Manufacturing Company stated that energy efficiency has officially surpassed pure computing power as the primary constraint on chip design. The massive power draw from current AI data centers is forcing a pivot toward architectural efficiency rather than raw clock speeds. The community is also discussing the pediatric autoimmune interferonopathy findings published in bioRxiv. The study identifies a link between SARS-CoV-2 and the onset of juvenile dermatomyositis, specifically focusing on how the MDA5 protein triggers immune responses to double-stranded RNA. This research is seen as a vital step in understanding the long-term impacts of viral-triggered autoimmunity. Emerging tools trending this week include a new open-source implementation of Claude code designed for local LLM environments, and the official Tor browser toolkit for secure, anonymous web access. Both tools signal a broader developer push toward local-first, privacy-respecting infrastructure. The pulse remains consistent. The ecosystem is moving away from cloud-dependent convenience and toward ruggedized, locally controlled foundations.